Number 63 in your classic for the unit circle, we want to find the quadrant in which theta can lie where cosecant is less than 0 and secant is greater than 0. So drawing the graph for cosecant first, which is 1 over sine of theta. Our graph on an xy, or graph, if we use this as our theta, and this is our cosecant of theta. Then cosecant, if we imagine that sine starts from 0, goes to 1, then drops it back to 0, and comes to -1 at, so this would be angle of pi over 2, this would be pi, this would be 3 pi over 2, and this is 2 pi. Our cosecant of theta starts from these points here at the maxima minima and jut off towards infinity with these vertical asymptotes at 0, pi, and 2 pi. And then cosecant also comes down this way. So actually, let me put that in a different color to make it a little easier to see. So our value for cosecant is given in blue. And so now we can make a sign chart of how it looks around the unit circle. So cosecant going in the first quadrant, which is from 0 to pi over 2, is obviously positive. So it's positive here. Then from pi over 2 to pi, it's also positive. From pi to 3 pi over 2, it's negative. And from 3 pi over 2 to 2 pi, it's also negative. So it basically has the same sign chart as sine of theta. And the same can be said about cosine of theta. So when we have our secant graph, secant of theta as 1 over cosine of theta, our sign chart for cosine of theta and secant of theta is going to be pretty much identical. So that means that we have positive in the first quadrant, then we have negative, negative, and then positive. So if we look for the place where cosecant is less than 0, meaning that we're restricted to quadrants 3 and 4, and also where secant theta is greater than 0, which means these two quadrants, 1 and 4, then they overlap in quadrant 4, meaning that theta can be in quadrant 4 for this problem.